If you haven't done so yet, please pause the video before moving on and try out the question. Of course, our first step in solving this problem is to try to draw a picture that's based on the description. And we can do that by drawing a point at which both people begin. One person walks in the easterly direction at 3 miles per hour, and the other person walks northeast at a rate of 2 miles per hour. And of course, the question is asking us how fast is the distance between the people changing. So why don't we mark the distance between the people? Now it's going to be convenient to assign variables to each of the three sides of the triangle. The next challenge is to come up with an equation that relates all three of these variables. Now this is not a right triangle, so we cannot use the Pythagorean theorem. But if we mark this angle right here with a capital C, it turns out that we're going to be able to use the law of cosines. So let's remind ourselves of that formula. Notice the difference between lowercase c, which is the distance between the two people, and uppercase c, which is the angle between sides A and B. It turns out that we know that angle. And the reason is that this line right here represents perfect north. This angle would be 90 degrees, of course. Well, because the person who's marked on path A was walking perfectly northeast, that means that that 90-degree angle was cut perfectly in half. So that makes this angle right here 45 degrees, or if we prefer, pi over 4. So in fact, capital C can be plugged in with 45 degrees. And we probably all recall that the cosine of 45 degrees is equal to root 2 over 2. And this 2 here and the 2 in the denominator can cancel. And then we can move this root 2 into the front of AB. So there is our simplified equation. Our next step is to differentiate the equation with respect to time. For c squared, all we need to do is pull the exponent down to make it 2c. We'll subtract 1 from the exponent, so it becomes c to the first. And then we multiply by the derivative of c with respect to time, which is dc dt. We're going to do a similar thing for the other terms of the equation. So this will become 2a times dA dt. The next term will become 2b times dB dt. The next term will actually require a product rule because we have the product of radical 2a as well as b. And so we'll have to use the product rule to differentiate that. Now the product rule, of course, goes as follows. We have the first function, radical 2a, multiplied by the derivative of the second function, which would be dB dt, plus the second function, b, times the derivative of the first, which would be radical 2 dA dt. Our next goal is to plug in all the known values, but first let's move the equation up to the top. Now we'll note that we have several distances to plug into the formula. We have lowercase c, a, and b. So our next objective is to find those distances. And to do that, we can remember, basically from physics, that distance is equal to a rate multiplied by the time. For example, to find the distance little a, we would have to multiply the rate that the person was walking at in the direction of little a, which was 2 miles per hour, multiplied by the time. Now, they were walking for 15 minutes. 15 minutes, of course, is a quarter of an hour. So we just have to multiply by 0.25 hours. And that gives us half of a mile. So little a would be half of a mile. Little b can be found in a similar fashion. We multiply the rate at which the person was walking in the direction of little b times a quarter of an hour. And when we do that, we get 0.75 miles. So we can plug that in for little b. The distance of little c can be found by going back to the law of cosines. So if we plug in little a and little b, which we just found, and also remember that the cosine of 45 is root 2 over 2, we're going to be able to solve for c. Now, c kind of looks like this after you take the square root of both sides. It turns out we can simplify this a little bit if we found a common denominator. So if you multiply the bottom and the top by 2, and then condense the fraction, and then take the square root of the denominator, we're left with that version of c. So we're going to plug that in everywhere we see a little c. Now for the rates, recall that the person that was walking northeast was doing so at a rate of 2 miles per hour. So dA dt will equal 2. The person that was walking towards the east was walking at a rate of 3 miles per hour. So dB dt will be 3. And dC dt is actually what we're trying to solve. So let's plug into this gigantic equation and then do our best to simplify. And then, of course, we'll divide both sides by this term right here. And we've done it. We've isolated dC dt. Since c is a distance, the numerator will have a unit of miles, and t is a time, so the denominator will have a unit of hours. So this will be in miles per hour. Of course, your professor probably wants you to simplify that. My suggestion is to use a calculator to get a decimal approximation. And when you do that, you get approximately 2.125, and as mentioned, the units will be miles per hour. Now, of course, it is possible to express in terms of an exact answer. If we use our calculators, we would see that this simplifies to 13 halves. We have the minus sign right here. If we simplified this term in the brackets, we would get 3 radical 2. And then this is still over this denominator here. Now this denominator you can reduce. That can cancel out and become a 1, and this can become a 2. I could then multiply the denominator by 2 as well as the numerator. With the numerator, just have to make sure to distribute. So that 2 will go here and cancel with that 2, and it'll also multiply here to make 6. And then the 2's here will cancel. I could then rationalize the denominator by multiplying the denominator by 13 minus 6 root 2 and the numerator by square root of 13 minus 6 root 2. If you'll notice, when you multiply the denominators, you're going to get exactly this value right here. So the term on the top and the term on the bottom will cancel, leaving you with the exact answer of 13 minus 6 radical 2, all of which is under a square root. So there's the exact answer.